No, I paid.
Whoa, this isn't for you guys. I better make a new page. You don't want all that. So what we're going to learn today is how to find a arithmetic, like an explicit or a recursive formula when you're given two terms in a sequence. And I thought I had these done, and I'm going to pause this real quick because apparently I need another 20 seconds. Good morning. So here's the gist. Today is the 13th. I was just reminded that tomorrow's Valentine's Day. So
I've been reminding everyone. Oh, I blew that.
For that.
I don't know what to call this, so I think we'll just kind of name it as we go. But the gist of this is that I'm going to give you two terms buried inside of a sequence, and your job is going to be to write the recursive and explicit formulas. So we'll start with probably just doing one of the formulas. I don't want to lose you over something silly at the end. So here's what you'll be given. This is what today's problems look like. So I have an arithmetic sequence, and I can tell you that this is a fact. And I can also tell you that this is a fact. So the goal for this section, by the way, we're getting close to where I can just get quizzes going on this. So a couple little things we have yet to do. So this is one of them. The idea is somewhere behind the scenes, there's a formula that produces these. Like it's on my note card for the record. But like the question is, if my teacher gives me these two random points in time. So what my teacher is saying is if I don't know where the sequence starts, but if I went hoppity hop 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 to the 15th platform, I would see the number 110. And then if I went hop 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 and it went all the way out to the 48th platform, I would see the number 341. So the math question here is like behind the scenes, what is the formula for this arithmetic sequence? Does any I don't think that would help us unless like we were trying to find the term that was halfway in between them. Like we could find their average, but that wouldn't really help us because I don't really want to know what the 29th or 30th or whatever that is. I don't want to know that. But your strategies, I'd like to hear them. Does anyone have any thoughts on how I could attack this and find the formula? It does involve some division at some point. The trouble right now is if you think about it, like you really don't know much. Like, okay, let's think about the two things that we generally want to know. And if you don't know this, I've failed you. The two things we really want to know when writing a formula for a sequence are, number one, where does it start? And number two is how does it behave, right? You don't know either. We agree? So the thought process is there some sort of cool way that I could backtrack and figure out, first of all, how does the sequence behave? Because finding the beginning is going to be not the first thing that we want to do. Eventually, we are going to have to go back and find a sub 1 because that's going to be part of our formulas that we have to write. But right now, my question to you is this. If Aiden is standing on the 15th platform and he has the number 110, and then way on down the line, Micah is standing on the 48th platform, and he's in possession of the number 341. In math, there's this thing called rate of change. Like, I don't know, if I told you that the temperature outside at 2 o'clock was 40 degrees, and then I told you that at 6 o'clock, the temperature was 80 degrees. This is a legitimate real life sort of thought process. So stick with me here. Could you figure out, this isn't perfect. Like in the real world, it's just a prediction. But could you estimate for me based on that information, on average, how much the temperature changed every hour? Like, I really don't want to spill the beans here. I want to see if you guys can figure that out. So I go outside and I take the temperature at 2 o'clock and I say, okay, at 2 o'clock, the temperature was 40 degrees. Yes. And then I go outside at 6 o'clock and I take the temperature and it's 80 degrees. Yes. In order to, I hear the number starting to creep in. That's great news. The idea behind this is if I can figure out two things. Number one, how much did the temperature change between my two temperature readings? How much did it go up? We all agree that it went up 40 degrees, right? And then the other question is, well, how long did it take for between readings? Very good. So if I did 4 hours apart and it was a 40-degree increase, my simple little brain, tell me if you agree with me, says I can take the full 40 degrees, and if I divide it by 4, then I should say I could be able to predict that at 3 o'clock, what was the temperature? It was 50 degrees because 40 divided by 4 on average means, in theory, it went up 10 degrees per hour. What was the temperature at 4 o'clock? What was the temperature at 5 o'clock? And there's that. What I'm doing right now is I'm just filling in an arithmetic sequence based on a simple division idea. If I know the temperature is 40 here and I know it's 80 here, and there's 3 hours in between, must go plus 10, plus 10, plus 10. That should make sense. Now, the question is, well, what in the heck does that have to do with what we're talking about? Well, it's actually got everything to do with what we're talking about. The idea here is, let's talk in terms not of temperature, but just in sequence values. How much did the sequence increase when it went from 110 to 341? It went up by 230. That's not rocket science. I just subtracted on my calculator. I didn't actually, but you could take the later one minus the earlier one and figure out how much it went up, right? Now, the other question is, and again, I get it. These are not clocks. These are not times of the day, but how many jumps had to happen? Like how many boop, 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 boops? Yes. So there were 33 movements that resulted in a net change of 231 value. So far, so good. And if we apply the same logic as we applied last time, by my math, I should be able to say the total amount something changed divided by how long it took it to change. That's called a rate. And that's all we're finding when we do arithmetic sequences. So since I don't have my calculator handy, 7. So what I figure out is by some pretty good wizardry, I just figured out that, holy crap, I now know D. D in this arithmetic sequence is 7. We need that. Halfway there. Like I said earlier, the two things you need to write an arithmetic formula, recursive or explicit. You need to know where does it start, and you need to know how does it behave. We've now answered the question of how does it behave. We've exposed this little rascal. We know that from term to term to term to term, he's plus 7, plus 7, plus 7. Okay, good. So based on some things that we've talked about, can we backtrack? Let me do an illustration of this for you. What we know right now, and I'm sorry, I'm not trying to waste your time, but I'm going to write out 15 blanks. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And by no means do I expect that you would ever want to do this again. I'm just doing this for your illustrative purposes. What is the 15th term of the sequence?
110.
So right here, I can put a 110. That is the 15th platform. Now, if I were really, really feeling like a masochist and just wanting to do a bunch of crazy extra work, is there anything stopping me from just working backwards until I can get to the first platform? I could just grab my calculator and type in the number 110 and hit -7. Why minus? I'm going backwards, right? So I could go -7, hit enter, -7, hit enter. But my question to you is like, ain't nobody got time for that, right? There's a better way. And it's just, again, using the logic. How many jumps do you have to make to go from the 15th platform to the first?
14.
So I'm looking at it like this. Wait, I'm currently at the number 110. If I go backwards 14 jumps, each of them with a value of how much? 7. And you might say -7, but I would call you on that and say, well, I've already got the minus in there, so I think I'm okay, right? Any flaw in the logic? I don't think so. I've got 110. I go backwards 14 steps, each step having a net result of 7. 14 times 7 is 98, and 110 minus 98 is 12. And you can now figure out that the first term of the sequence is 12. So we have fully cracked the code at this point. We can say two things, and they're the only two things you need. You need to know the first term, which we got it, is 12. And we need to know the common difference, which we figured that out 4 minutes ago. That is 7. And if you know those two things about a sequence, 100% of the time you can write a formula. So are we okay so far? The rest of what I'm asking you to do has nothing to do with mathematics. That was very mathy. This is not. This is just plugging stuff in. So the first thing we're going to do in our notes is we're going to write the one you guys should like better. And we're going to write, because you have to do both of these on today's assignment. We're going to write the explicit formula. Everyone likes explicit formulas better. They're so much more useful, practical. So the explicit formula, you have it in your notes, but I thought I would just refresh your memory real quick. The explicit formula will always be a sub n equals a sub 1 plus n minus 1 times d. Like if you went back in time like a week and a half, you would find that right in your notebook. Explicit formula. There it is. So what we're going to do is we're going to replace this red box with what number? And we're going to replace this green box with what number? And just like that, you will have yourself the explicit formula for the mystery sequence that was on the board. So our explicit formula for this example is going to be a sub n equals 12 plus n minus 1 times 7. And I do get some comments about parentheses versus like not parentheses. I have no issues with that. Where I would have an issue with that would be if the 7 were a negative. Because if I put like, and again, I'm just making this up, but let's just say that d were -7. What does that look like? Right. Like no one in their right mind, no one who knows anything about math would ever question that 7's role in this answer. Like you stick things together from the age of like 11, you know that means times. But when you put a negative on there, it can look a little weird. So if you want to just practice safe math and always play it safe, you can always put double parentheses. Put parentheses around your n minus 1, put parentheses around your d, call it good. Like no one's going to complain about that. Good. I would also like us on every problem to write the recursive formula. And you might remember that the recursive formula, see, explicit formula is dope because it's one-stop shopping. You write the explicit formula and you're good to go. The recursive formula requires two pieces. Does anyone remember what two things I need to write a recursive formula? You need two. It's got two parts. It's annoying. What's the first thing it needs? Yes. Yes. The first part of a recursive formula is you have to say, I'm going to draw a line so that this, I mean, I'm a little worried that I'm just rambling here. So this line is going to separate explicit from recursive. To do a recursive formula, you need to start by stating what the first term is. So I can cover that. What's a sub 1? Good. That's part of the deal. You write recursive, you tell someone where to start. Like, we did that. We found that. It's pretty cool. And then the other thing we have to do is tell them just the behavior of the sequence. And the recursive formula would just be like this. A sub n equals a sub n minus 1 plus 7 done. Notice that the number 12 isn't really in the recursive formula, not the bottom part. So you're going to get to practice this. We'll do another one, maybe two together here. I've got a bunch queued up, but we'll do at least maybe one or two. And then if you still feel like, boy, it's not setting in, we'll do a couple more. But then I have an assignment of just this. Okay, I'll give you the 34th term. I'll give you the 95th term, and you figure out the sequence. Go. Good. All right, I'm going to pause again so I can do a little bit of math, and I'll be. I don't know how that felt. Was that super confusing, or did you guys kind of get the vibe of that?
It's fascinating how.
Oh, I'm glad to hear you say that. That's nice. Thanks. I mean, I don't think that was a compliment, but still, thanks. For this one, I'm going to tell you that a sub 48, also known as the 48th term of the sequence, is negative 145. And then I'm going to head way on down the line, and I'm going to tell you that the 112th term of the sequence is negative 337. Then we're going to do explicit and recursive. We're basically going to just redo the last problem, exact same expectations. We're going to write explicit, and then we're going to write recursive, right? And this time I don't have to go off to the side and give you the side lecture about the temperature change. You should already probably have like figured out, okay, I need two things. I need how much the sequence changed. So when I think about my early snapshot of the sequence, it was at negative 145. And then a few minutes later, it was at negative 337. So the first thing I need to figure out is how much change occurred for negative 145. So it went down by 192. Thank you for calculating that for us. And the other question that I have is how many steps did it take to get there? And Dalton has already done that math for us. For the 48th term, to move from the 48th platform to the 112th platform, you have to move 64, did you say? Good. Those are the two critical components. Again, much shorter explanation this time because you get the whole temperature analogy here. So if something changes by negative 192 and it takes it 64 moves to do that, how do we calculate the actual amount per move? The question is how. You divide. And this will be good for you in real life. If you ever want to know how much something costs or whatever, just divide how many of them you're getting by how much you're paying total, or divide how much, I said that wrong, divide how much you're paying total by how many you're getting, and you can figure out it's called a unit cost or something. It's all over in the real. So if I take the amount of change, negative 192, and I divide it by the number of moves it took to get there, I will figure out negative 3. And what that means now is we've cracked the code, and we now know that behind the scenes, what's happening is every time in the sequence when you go hop, 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 hop from term to term, you just go -3, -3, -3, -3. So at this point, this is a huge piece of information. D is -3. You should write that down 100% of the time. And this is always going to be, I think, the tricky part. So what I'm telling you, and this time maybe I should have chosen a different number, but what I'm telling you now is that when I stand on the 48th platform, so if I start at the sequence and then I go hop, 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 and I run out 48 steps and I stand there, I am now associated with the number negative 145, right? So let me draw some sort of half-hearted diagram. I'm not drawing 48 blanks. Just FYI, so I'll draw a few. So here's there it is. There's the first term, here's the second term, here's the third term. dot, 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 and then I'll just do a few more. So based on what my teacher told me, the 48th term, so I'm going to put that down here. That's a sub 48 is negative 145. We good? This is one of those lessons that unless you're willing to like be a part of it and actually be awake and thinking, there's no way to get through this. So I hope you're staying strong. Let's talk common sense. If the sequence is going down by 3 each time, what I'm going to try to do is I'm going to try to chuck my way back to the beginning. I'm like working my way back up. So if the sequence is -3, if I go backwards 1 step, what is that? I'm going to add 3. Very good. So if you think about it, like the number before it, you don't need to know this, but I'm just telling you, like the number before was obviously negative 142. What came before that? Yeah, and again, unless you're some sort of weirdo, like you're probably not going to do this process all the way back to the first term. We return to the conversation about, okay, if Aiden wants to go from the 48th platform back to the first platform, how many jumps does he have to make? He has to make 47 jumps. And how much is each jump worth since he's going backwards? +3, because he's going backwards. And where is he starting his journey? At what number?
-145.
Yes. So if Aiden starts at negative 145 and he makes 47 positive jumps of 3, then he multiplies that out. 47 times 3 is 141. That should be a -4. Now what we've done is we've officially cracked the code. We're like, I know everything about you now, you stupid sequence. I know your a sub 1 is -4 because I went big brain and found it. And I know your D is -3. And I can now piece those two things together to write my formulas. In which context? Like which part are you talking about? This bottom part down here? I know because when I'm working my way back up, so follow my purple arrows. You would agree that since the sequence, when you're going this way, it's -3, -3, right? So obviously if you go the other way, right. Okay. So let's get to it. If I know A sub 1 and I know D, there's nothing stopping me now. All the hard work is done. Now it's just compliance, like plugging stuff in. So what is my explicit formula going to be? Couldn't have said it better myself. That's explicit, done. And explicit, remember, is so rad because it's one-stop shop. Like you don't need extra information. Explicit is everything you need in one package. Now we need the recursive. What's that going to be? Remember, the recursive consists of 2 parts. So this one is explicit. You mean A sub 1 equals -4. So remember, you state right out of the gate for recursive. I'm sorry if I said explicit. I do that sometimes. For recursive, you state right out of the gate, this is the first term. We found that. Pretty tough. What's the other part of the recursive? Yeah. Recursive is just like the behavior formula. I don't know what's more beneficial. Would you guys like to do another one together, or would you like me just to print your homework and we get working? Just want me to print it and get going? Okay. I'll do it. What I'll do is I'll probably, again, you're all here. So if you were to go back and watch the recording, I'll pause this and I'll do like a problem together, perhaps. That way we're doing another problem together, but it's like towards getting the homework done. And I'll record that. So, yeah. So the first problem we are told, and sorry, my eyes they don't like this. I like the dark, but I don't like trying to read in the dark. So the first problem is at the 16th. What does that say? So the 16th term is 285. And that second one is the Gosh, I wish I could make that font a little bigger. I want to go back in time and have younger eyes. There. All right, so let's see what you've learned. The goal here, remember, is this is operation find the D, operation find the A sub 1. And if we can do those, then the rest is just write the dumb formula. So here it goes. Step 1 is to figure out how much did the sequence value change. So the question is this, and we're just going to follow the colored arrows. How much does 285 change to become 745? Perfect. Thank you, Trinity. So that means that we've had a net change in our sequence of up 460 total units. How many steps did it take for the 16th term to become the 39th term? It took 23 steps. Got it? So what we do now is we divide. In life, you divide how much something changes by how long it takes, and you can find something called an average rate of change. And what is 460 divided by 23? Is exactly 20. So we just figured out that D is 20. And if you don't know what that means, it just means that every term goes up by 20. Add 20, add 20, add 20. That's all. Simple. So now what we want to do is we want to backtrack. We want to say, okay, here I stand on the 16th platform, and I am with the number 285. If I work my way back to the 15th, and then the 14th, and the 13th, and the 12th, and the 11th, and I go all the way back to the first, how many moves do I have to make to go from the 16th back to the first? Correct. So I have to take 15 jumps. And what is the value of each of those jumps as I go backwards towards the beginning? Each one is negative 20. And that goes back again. Diedrich, do you understand why it's negative? Because we're going backwards. If the normal sequence is going up by 20, if I'm going backwards, of course, I have to go down by 20. And where am I beginning my journey from? What number? Correct. So the math of it looks like this. I am at 285. I am going to perform 15 jumps, each jump with a value of negative 20. And when I type that happy little math problem into my calculator, it's poof going to reveal what the first term is, which is negative 155? Negative 350? I don't think so. You might want to. Yeah, phone's on vibrate. Can blow us up. I did. Oh, I got to pause this. Hold on, recording. So what this tells us when I put this math in my calculator is that if I go back to the very beginning of the sequence, the very first term, you know, A sub 1, it would have been negative 15. And now we can just do the formulas. There's no more thinking at this point. That's like thinking. You have to think. Sorry, this part, I know that sounded weird. This part is just robot work. So here it goes. Right. So here it goes. For our explicit formula. So Micah gave me the last one. I don't want him to do this one. Can I get a new voice? Who wants to read me the explicit formula for this sequence? It's not because I don't like Micah's voice. It's just that I like to, let's spread the wealth here. Haley, Trinity, anybody? Foxy? A sub n equals. Yes. Plus, forgot the plus, n minus 1 times times 20. Because the sequence naturally is increasing. Remember, we only use negative because we were working our way back to the beginning. Nice job there, Foxer. Yeah, that is finishing it out. Like, this is just writing formulas. So, yep. Really, 98% of this assignment today is searching for these two things with the purple check marks. And then the rest is just, yeah, formula. All right, how about recursive? Anybody else want to give it a shot? I need two things for my recursive formula. Evie, you want to give it a go? Okay. Kind of, you forgot about the left side, so let's do that first. So we need a sub n equals. All right, now I'm ready for that. Yep. Plus 20. Yes, this one we're actually describing the behavior as plus 20. The 20 interestingly gets multiplied over here because it's like a different view of the same thing. So this is good, but what else do we need to complete the recursive? Yes, an a sub 1 has to be there. So let me put some boxes around this just in case this hasn't been made clear yet. This yellow box is one answer. That is called the explicit formula. This red box is the other answer, called the recursive. And that's what I want you to do 11 more times on that worksheet. Think you got it? Vamos a hacer estas problemas otra vez mañana. Pueden usar 55 minutos mañana para 10, 11 problemas. Y la fecha de entrega es jueves para estos problemas. Vamos a hacer práctica. What did I say, like práctica prueba? Prueba de práctica?
Okay, how many people do you actually think you understand?
No sé.
Okay, wait. That's 1 out of.
I'm not going to do any more problems on the recording. I feel like any more would just be like, I don't get the point. Like I think we did 3 or maybe 4 together. So that should be abundant. So I'm going to stop this.